Hey guys, good morning, good afternoon, or good evening, whatever time it is for you. If it's your birthday today, happy birthday. Just hanging out with the dog here, and I thought I'd show you somewhat of a complicated brain teaser. At least it was for me. It took me a little bit of thinking to figure this out, and I wanted to pass it along and hopefully show a trick or two. So this part here was being machined, and then we had a failure on this bore here, so the part had to be taken out and re-welded. And this bore here represented the X0Y0 work offset in the program, work offset number 1. And so these bores were good, great bores, and they were machined with a finished bore, so they're pretty accurate. So what I needed to do when we put the part back in the fixture is to find this location, which is number 2. What is the machine position of this bore here? And what angle is the part sitting in the fixture? So this particular part gets machined with rotation. As each detail gets cut into the part, rotation comes on, where when the probe originally picked up the part, the probe calculates the angle that the part is sitting in the fixture. So we need to manually figure out what that is, because you can't reprobe this part with weld here. So let's get to it. So the print is calling out a delta distance here of 254 in the X and 387 here in the Y, the distance. So what I'm going to do here is figure out what this angle is, and figure out what this angle is, and subtract the angles. And when you do that, it will give you the rotation that this part is sitting in. So you see that the numbers are a little bit off. 254.474 and 254. 387 is 386.616. How did I know that? I picked up each bore and wrote down the machine position of what that was, and then I figured out what the deltas were. The delta just represents the distance, for the X distance from this bore to this bore, the Y delta, or the Y distance to that bore. And I made a note of what that was. So you take the machinist calculator here. It says 386.616, 386.616 adjacent, okay, 254.474 represents opposite. Now we'll push angle to find out what that angle is. And it says 33.3533 degrees. And we will write that whole thing out. 33.353 degrees. Okay. Push clear. Now we come down to here, and what is the print, what is the angle of this according to the print? So 254 is opposite, 387 is adjacent. The angle is 33.2781. So we'll write that on here. Now, if you subtract those two angles, 33.353 minus 33.2781, it equals 0.0749. So that answers question number 1. The part is sitting in the fixture at a 0.0749 degree. So the next question is, what is the machine position? Okay. So we know on the print that it represents 1520 millimeters to here. So so what you're going to need to do is if you put this in as your X0, Y0 on the machining center, and you apply this 1520, and this is Y0, so you apply the 0.0749 of rotation. That will give that to you. So call up, before you do that, before you put that in there, it's a good idea to call up this bore first. So 254, 387 with 0.0749 of rotation, and just verify that this machine position, that the machine goes to this position with the rotation on. If it's way off, change that to a minus, or vice versa. If you had that as minus, change it to a plus. And it should be exactly at this location. So first get your minus and plus done, then call this bore up. And if when you call this up it's correct, this is automatically going to be correct. So now that you know the machine position of this, you can double check your work by calling up this bore. Since you already know this and this, call up the bore. Machine should go to this position with rotation on, and this as well. So I hope this helps, and have a great day. See you in the next video.